Hello and welcome to this webinar. I'll start off with a short introduction about who we are. Element is a global testing, inspection and certification company. In Connected Technologies, we focus on EMC, radio, safety and hazardous area testing of electrical and electronic products. And within the electrical safety testing business, we cover a wide range of products including batteries, consumer products and appliances, commercial products, medical devices, laboratory equipment and industrial equipment. Along with our certification body, we operate several 17025 test laboratories across the UK, USA and China, and also provide global market access and advisory services. During the next half an hour or so, I'll aim to provide a brief overview on the key drivers behind safety testing and certification of electronic and electrical products to understand why we in the compliance industry do what we do. I'll then go over the testing and certification process itself and follow up with a discussion on where we often see customers trip up along this process, causing projects to get delayed or overrun. I'll finish off the webinar by introducing the IEEE-CB scheme, which is generally seen as the most cost-effective way to demonstrate that your product meets the safety requirements for the majority of international markets. And then I'll answer a few of the questions we received. So, on to our first topic. The majority of companies test their products to a publicly available standard and involve third parties in the testing and assessment process for one of the following four reasons. The most obvious and the strongest driver is when a country sets out the requirements to use a standard in the legislation, in order to reduce the risk that unsafe products are made available on the market. Mandatory third-party testing or certification requirements are usually but not always reserved for products which are perceived or have been shown by historic data to carry a high risk of injury or damage to property if not designed correctly. In Europe and the UK, the use of standards are generally voluntary. However, even here, to effectively demonstrate that you have met the requirements of the legislation, the use of standards essentially becomes required due to the vague nature of that legislation. Even when not required by legislation, entirely voluntary standards or certification marks can become required where these gain recognition by consumers or an industry. Either a competitive advantage can be achieved, or it can even become difficult to sell the product without displaying the certification on the product or stating that your product meets the requirements of the standard in marketing material. Often the demonstration that a product meets a specific standard or has a certification can inspire genuine confidence. However, the market may be made aware of these standards or certifications by seeing them applied to higher risk products, but not understanding exactly why they have been required. A classic example of this is the NRTL certification used in the USA, which is often incorrectly thought to be required for all electronic goods placed on the market in the United States, but is in fact only required in limited circumstances, such as for electronic equipment used in the workplace or equipment used in hazardous areas. In order to help ensure that companies or organizations are buying safe products to sell on or for their employees, they will often stipulate in their purchasing contracts that the products they purchase must meet the requirements of a specific safety standard or have been tested and approved by an appropriately accredited third party. Internationally, the approval required is normally a CB certificate or a test report from a 17025 accredited testing laboratory. In the USA or Canada, the requirement is normally that the product is certified or listed by an NRTL. Organizations may choose to maintain quality and protect their brand by dictating in their quality procedures that the products they design or use should meet relevant national or international safety standards and that third-party testing is carried out. Including this as part of routine product development and purchasing procedures can prevent costly incident or brand damage due to unsafe products being placed on the market as a result of intentional or unintentional shortcuts taken due to the normal cost and time pressures faced by all companies. So that brings us to the end of the why section of the webinar, and we move on to the how section. So for whatever reason it is needed, the process to achieve this testing and certification can be split into the following 6 phases: the pre-testing or product development, the requesting of the quote for the testing, the preparation for that testing, the testing program itself, the certification review, and the post-testing and certification obligations which apply to manufacturers. Ideally, the compliance journey for a particular product should start when the specifications for that product are being defined during the product design stage. At this point, the technical standards for that product should be identified so that software, enclosures, circuits, controls, etc. can be designed according to that standard and suitable materials selected. Even at this stage, it is not too early to approach test houses for assistance. Many, including Element, can provide advisory services to help identify the standard and regulatory requirements based on the product details and the markets you're thinking of entering. They can provide you with a compliance roadmap so that you know where you're going at the start of your journey. Your designers should have copies of the relevant standards, and an appropriate person within your company should have an understanding of the particular testing and certification or regulatory requirements which need to be met. When circuit diagrams and detailed product specifications and drawings have been produced, these can then be submitted to a test house for review to identify any potential areas for concern which could result in failures during the final product testing and assessment. Additional limited clause testing and assessment can be undertaken on early samples of a product or manual to verify that they meet key potential problematic areas of a standard, such as the instruction and marking requirements, creepage and clearance distances, stability requirements, or to ensure that materials have appropriate flammability resistance. When you're ready to get a quote for your testing and certification project, then you'll need to provide us with a few details to describe what your product is and what it does. This will include its overall size and weight and electrical or other ratings. Often an instruction manual or datasheet will be enough to at least get the process started. The sales team, yourself, and operations will then coordinate to determine the appropriate standards, certifications, approvals, or other services which you require. These discussions will focus around the following factors which will affect your quote: the standard or standards which will be applied, and if there is an applicable product-specific part of the standard. If the safety of a product relies in part on the prevention of water or dust, then ingress testing may be required. The markets you may want to access, so the appropriate national differences can be considered. If certification or notified/approved body approvals are needed, or if you'll be okay with just a 17025 accredited report. Whether all safety critical components come with appropriate approvals, or if some of these will be required to be tested in the product. How complex your product is and what features or accessories it has. Perhaps unsurprisingly, a complex product with a range of PCBs and hazards, for example lasers, pressure vessels, or high voltages, will require more time and therefore more cost to fully evaluate. If your product depends on software for safety, this will also need to be assessed. How your product is powered. Mains and battery supplied equipment can require more testing than DC supplied equipment due to greater hazards. If testing is needed to be undertaken on-site due to the specialist equipment required to operate your product, or for large products which are difficult to transport, allowance needs to be made for the test engineer's travel expenses. When requesting a quote, try to provide us with as much information as you can. Otherwise, assumptions may have to be made which could result in increased quote costs or project delays. At this stage, you should have received our quote, and on this we will have provided you with an initial list of documentation which you will need to provide, ideally prior to the commencement of the testing. If not compiled or created already, now's the time to get this documentation together. You'll need application forms, completed, circuit diagrams, engineering drawings and block system diagrams, rating label drawings and details about warnings and markings which will be on a product, components lists, details about alternative components, manufacturer's data and approval certificates on polymeric materials used for enclosures and PCBs, datasheets and approval certificates for critical components, installation and user instructions, and where applicable, supporting reports for aspects of testing which are required but may not have been covered in the quoted test program, for example, software assessment, laser assessment, or ingress protection test reports. We should also have indicated the number of samples we require and if they need to be set up to operate in any specific manner. If more samples can be provided than what is needed, this can allow us to conduct testing in parallel to reduce test times, or reduce the chance of delays if testing damages a sample, or sample ceases to work for any other reason. You will also need to provide any specialist equipment or accessories to allow the product to operate as intended. In some cases, this may require you to supply a test rig. Where safety critical components are not able to be supplied with the appropriate approvals and additional testing is needed, we will also need separate samples of these components. If you plan to use multiple suppliers for certain safety critical components, samples from these suppliers may also be required. At this stage, we will assess your product against all relevant requirements detailed in the safety standards identified as applicable to your product during the quoting stage. The safety standards will consider the hazards associated with your specific product type, taking into account where it is intended to be used and who it may be used by. Whilst there may often be a focus on risks from electrical hazards, test projects will seek to address all hazards related to that product, including fire, mechanical, thermal, radiation, and acoustic hazards, among others. When the product is with the lab, compliance with the standard is demonstrated through the following three key areas: the inspection and measurements, review of the documentation, and dynamic testing. The inspection and measurement of the product will consist of activities such as a review of the earthing system where applicable, ensuring components are being used correctly, measuring cleavage and clearance distances, ensuring no hazardous parts are accessible, software evaluations, etc. During the documentation review, the instruction manual will be assessed to ensure it meets the requirements of the standards, and critical component information will be examined to ensure that components used have the appropriate approvals and are being used in line with their intended use. And the dynamic testing will include aspects such as enclosure ingress testing, thermal testing to ensure key parts of the product are not exceeding allowed temperature limits, input testing to ensure the measured current or power are as per the markings on the equipment, touch current tests to ensure that no high currents are accessible to the user, and testing to ensure the equipment remains safe under single fault conditions. After the testing, assessment and documentation reviews have been completed, the test engineer responsible for the project will write the report, indicating which clauses are applicable and hopefully that all relevant clauses have passed. Where appropriate, comments will also be included. This report will then be reviewed by an authorized reviewer at the test lab. The test lab will also keep copies of all test results, worksheets and documentation supplied in the project file as is required by the IEC and UCAS accreditation. Where non-compliances to the requirements of the standard are identified, the test lab will issue a findings email detailing the non-compliances and allowing you the opportunity to rectify them. This may require an update to your product design, providing additional documentation or updating the manual. Where testing cannot continue, you will be provided with a time frame of normally 10 days in which revised samples, information or documentation attempting to rectify the non-compliances should be received by the lab before the project is closed. If you require more time to resolve any non-compliances, you should discuss this with the laboratory as soon as possible. If additional testing time is required due to failures or product specifics which were not known at the quoting stage, this will be agreed with you via a change order request, which will need to be approved by you prior to any additional testing being undertaken. After the report is written, the testing laboratory will submit it to the certification body for their review along with the supporting documentation and application form. Where a quality audit of the manufacturing location is required as part of the certification scheme, this will also be organised and an audit report produced. Successful completion of this process will result in the certification being issued. Where audits at manufacturing locations have been required, surveillance audits or follow-up inspections will be needed at a frequency determined by the certification scheme or body. So long as a product is still being manufactured, you will need to keep abreast of changes to the applied standards or legislation and evaluate if any changes will require additional testing or updates to documentation. Certification bodies may also send out notices when standards are updated, detailing these changes and whether additional evaluation is required. Under certain schemes, where non-certified critical safety components have been used, these will have to be retested on a yearly basis. Product design, component or material and supplier changes will also need to be monitored and testing and certification updated where changes are notable. Updates will also be required where names and addresses listed on the certificates are changed. The compliance file for a product should be treated as a living set of documents until that product ceases to be manufactured or placed on the market. Perhaps surprisingly, the testing part of projects and failures of tests are not where we see the majority of project delays. Of course, product redesigns due to test failures can cause significant delays to an overall product launch, but the most common delays we see on test projects relates to documentation or administrative issues, which can be considered good news as these are the easiest to identify and fix. The most common issue we see is related to missing or incorrect documentation. For example, application forms are often provided with incorrect product name or model. This may seem like a minor issue, but this can cause delays during reviews and can take time to confirm the correct names and model numbers and then update reports before sending them through the review process again. Also, declared electrical ratings are often incorrect or different to what is marked on the product or in user manuals. Circuit diagrams and detailed design drawings may be missing for bought-in items without approvals, such as motherboards. Manufacturers might find it difficult to get this information, so it should be considered during the design phase of the equipment and when selecting components, so suppliers can have enough time to produce this information prior to the final equipment safety testing. Instructions are a key part of the assessment, both to allow the test engineer and users an understanding of the product and to inform users about residual risks or limits of how the equipment should be used. Most standards include specific requirements on what information is needed to be communicated to the user and in what format. This is a key area which can delay projects, and it is very common that either instructions are not received or those received have not been written considering the requirements of the standard. The good news is that it is also simple, but not necessarily quick, to rectify, as standards are quite clear on the instruction manual requirements. Another simple fix relates to incorrect markings, warnings, and symbols. Again, standards are often explicit in relation to the symbols and markings required on products, and a fairly simple checklist can be produced to help ensure that the product is supplied with these. Where symbols are used, these should be in the appropriate international symbols as referenced in the standard, e.g. symbols from IEC 60471 or ISO 7000. The marking should also be sufficiently legible, durable, and indelible. Straightforward rubbing tests for durability are included in the standard. Where approvals for components, critical components, and materials are supplied, the limits of use should match with your product's limits. For example, indoor-only power supplies cannot be used with products which are intended to be used outdoors. Or if your product is intended to operate in environments over 40 degrees centigrade, then the approvals for the components also need to show that they are intended to operate in the same environments. Additionally, it should be noted that national deviations also apply to some component approvals. So if you request that we assess your product for a particular national deviation, then your power supply and battery approvals need to also state that these have been approved for the same national deviations. So we know the correct information needs to be supplied, but in order to minimize the risk of delays, it is also important that it is supplied on time and it is all available prior to the start of testing. Where requested, we will try to work with the information we have been provided if it is not complete and begin areas of the project which are not reliant on the missing information, but this piecemeal approach is not an efficient way to run a test program and significantly increases the risk of delays. Unsurprisingly, final, complete and representative samples need to be available in sufficient time to allow the testing to be scheduled in accordance with any agreed timeframes. Equipment also needs to be in an appropriate state and provided with specialized supporting equipment or consumables needed to operate or verify the product under test. Risk of delays can also be reduced by supplying spare product samples and safety critical components, e.g. fuses, thermal cutouts and transformers. Delays caused by test failures can be varied and often depend on the product type or standard. But some of the more common or notable issues we see include insufficient creepage and clearance distances, heating test failures, battery charge protection failures caused by batteries which don't stop charging at the battery manufacturer's temperature limits, failed stability, force or tilt tests, and ingress and enclosure test failures, either due to inherent design, incorrect tolerances being specified, incorrect assembly of samples, or sometimes the requirements to condition the samples prior to the testing have not been taken into account during the material selection or design phase. There are many certification schemes available, but arguably the most important one for electrical product safety is the CB scheme. The CB scheme, or to give it its full name, the IEC-EE CB scheme, is an international certification scheme to allow international mutual acceptance of test reports and certificates between various member national certification bodies, or NCBs. The aim being that you can get one test report and use this report to get local certifications in any of the 54 member countries without the need for time-consuming, costly, and duplicate or additional testing in each country. The scheme is primarily based on the use of IEC international standards that can be readily accessed and accepted in international markets. It is also managed by the IEC, or International Electrotechnical Commission, whose aims are to ensure safety, efficiency, reliability, and interoperability of electrical, electronic, and information technologies to enhance international trade, facilitate broad electrical access, and enable a more sustainable world. The process to get a CB certificate is summarized in the following flowchart and is much the same as the process discussed previously, but there's no requirement for an audit of the manufacturing location. In short, an application is made to the national certification body through the submission of an application form. Then the NCB will process the application and assign one of its CB testing laboratories. You will then submit a representative sample of your product and relevant documentation to the CBTL. The CBTL will carry out the testing and assessment of your product to the relevant standard, which is within the IEC-EE CB scheme, including any declared national differences where requested, and then issue the test report to the national certification body. The NCB will then review and validate the test report, and on completion of a successful review, they will issue a CB test certificate and the report to you. You can then take the certificate and report and submit it to recognizing NCBs to gain local certifications, or national regulatory authorities, retailers, buyers, etc., as evidence that your product design meets the safety or other requirements of the relevant standards. By now, it's probably not going to come as a surprise to you that elements are part of the CB scheme. We have a UK-based national certification body and currently 6 CB test laboratories specialising in product safety testing, with 2 in the United Kingdom, in Hitchin and Hull, 2 in the USA, and 2 in China. Under the IEC EECB scheme, we can currently offer testing and certification for 8 IEC categories, including batteries, EMC, household, ITAV, electronics, office equipment, measuring equipment, and medical equipment, covering standard series such as 62368, 60950, 60065, 60335, 61010, 62133, 60601, and for EMC 60601 and 61326. During the registration process for this webinar, we asked if you had any questions, and we received a number of responses. The following questions have been selected from this list. So the first question, how do we know which standards are relevant to a particular device? Well, clearly the standard or title of a standard can give you an immediate indication of its applicability. But to definitively know if a standard is relevant, you're going to need to review the scope of the standard. You can view the scope of a standard prior to purchasing it on websites such as the IEC Web Store, the ISO Store, and the UL Standards Sales site. If you're unsure about which standard to search for, you can match your product type to an ICS, or International Classification for Standards code, and search for standards in this way. Or you can search online for datasheets, declarations of conformity, or certificates for similar products and see what standards other manufacturers have applied. Finally, you can also approach a test house for a testing quote, or for more unusual products, advisory services can produce compliance roadmaps which will provide a detailed and definitive answer. The second question is, can variants of the same product be listed under one report? This will depend on the extent of the variance and the type of report or certification scheme. However, as an example, under the CB scheme, if variants or a product family all have a common design, construction, parts or assemblies essential to ensure the conformity with the applicable requirements, these can then be included in one report and certificate. And our third question, can manufacturers self-certify their products for electrical safety in the EU and UK, or is third-party approval required? In general, third-party approval is not required by UK or EU legislation for electrical safety testing. However, some legislation does require notified or approved body involvement for certain high-risk products, such as high-risk medical devices or Zone 0 and Zone 1 ATEX equipment. Third-party approvals are also needed where harmonized or designated standards have not been applied in full for high-risk machinery and for certain aspects of radio equipment approvals. And that brings us to the end of this webinar. Thank you to everyone who joined, and especially to those who submitted a question. Apologies if I've not managed to answer your question during this webinar, but we will try to reach out to you directly to discuss how we can help in more detail.